This little RF signal generator has some issues. It's a nice little device, so I'll try to get it working. I bought it from an auction for just under €40. It works over all the ranges from about 113 kHz to about 138 MHz. The wave shape is not very beautiful, depends on the frequency. At the low end, it's nothing like a sine wave. It may be intentional, as there are markings on the dial for the highest range for calibrated harmonics up to 260 MHz. Also, the amplitude varies widely. It can provide several volts at the low end, but only about 50 millivolts at the top end. There is a 400 Hz AF modulation oscillator, which provides up to a couple of volts at the AF output, variable via potentiometer. Modulation depth is fixed at perhaps 30%. The tube on the left is the LC audio oscillator. If the switch is in the internal modulation position, the audio signal goes to the grid of the oscillator tube and to the audio output via a potentiometer. The modulation depth is preset by a voltage divider. If the switch is in the external modulation position, the audio tube is connected as an amplifier, and its output goes to the grid of the oscillator tube as before. The modulation depth is adjustable via the potentiometer. On the right is a dual triode. The right-hand section is a Colpitts oscillator, which feeds to the grid of the left-hand section, which is connected as a cathode follower. The output of this goes to the RF output via a potentiometer and a voltage divider for the low-level output socket. The power supply is half-wave rectified and filtered by a 10 microfarad capacitor, a 3K series resistor, and another 10 microfarad capacitor. This is what the inside looks like. In the middle we have the tuning capacitor. Bottom left is the choke for the audio oscillator. Bottom right is the mains transformer. On the little platform is the double triode for the oscillator, and the tube at the towards us is the audio oscillator tube. And then you can see on the left the band switch with all the coils and the broad strips going to the tuning capacitor. Here we see a bottom view of the instrument. We can see that someone's been in before and has probably changed the dual-core mains cable to a 3-core earthed cable and installed an earth connection and 2 fuses in the primary side of the transformer. The blue thing with little fins in the middle left is the selenium rectifier, and then the mains filter capacitor is the big black one at the bottom. The pilot light, you can see, I will talk about that later. I have changed to a LED device instead. When I got the instrument, I found that the filament voltage on the tubes was too low, below 5 volts. And it turned out that somebody had replaced the pilot lamp with one which was too powerful. So that dragged the voltage down. So I decided to replace it with an LED. I was inspired by a video from Electronics Old and New by M Caldeira. I will put a link below to it. What I did was I took the old pilot lamp, broke the glass and took that off, and then installed this circuit instead with a super bright red LED, a 220 ohm resistor, and a 1N4148 anti-parallel diode. And that worked very well. And then the filament voltage returned to normal. Someone had done something bad to the 6AR5 tube because its pins were bent. So when I pulled it out to check why the filament voltage was too low, which it was when I measured to begin with, one of the filament pins broke off, so I had to replace it. Unfortunately, these are very expensive and hard to get because apparently they're used in guitar amplifiers. So I replaced it with an equivalent, more or less equivalent tube, the 6AQ5. The problem with that is that it turns out that the grid is also connected to pin 7 on that tube, and pin 7 in this instrument had been used as a binding post for a capacitor, the 0.01 capacitor which you see in the blue circle. So I had to disconnect. The effect of this was that the grid got connected to the plate voltage when the instrument was switched to internal modulation. So what I had to do was disconnect the capacitor from pin 7 and connect it straight to the switch instead. So you can see that the disconnection was where the blue arrow is. When I did that, everything worked as it should. Another little modification I made was to avoid DC potential on the output. I disconnected the output wire from the output potentiometer and put a 1 microfarad 100 volt capacitor in series, which you see in the middle of this picture. You can see the output from the generator at 120 kilohertz, and here at 500 kilohertz, and here at 2 megahertz, and here at 6 megahertz, 20 megahertz, and 100 megahertz. Just for fun, I thought I'd have a look at the signal on my old HP spectrum analyzer. This is at 120 kilohertz. Fundamental is the large peak right at the left at 54 decibels millivolt. So you can see the fundamental, and it's 100 kilohertz per division and 10 decibels per division vertically. So you can see that the fundamental is at about 120 kilohertz and about 44 decibels millivolt, which is about 128 millivolts, I think. And the second and third harmonics are about 6 decibels down. This is at 500 kilohertz. Larger fundamental works out at about 250 millivolts, 500 kilohertz per division. And the second and third harmonics are rather lower at about 12 decibels down and more. Here we have 2 megahertz, even larger fundamental, quite high second harmonic, and rather lower third and fourth harmonics. This is at 2 megahertz per division. And here we have the spectrum at 6 megahertz, 10 megahertz per division. Now the spectrum at 20 megahertz, 20 megahertz per division. And now the spectrum at 100 megahertz, 100 megahertz per division.